my name is Kevin Keller. I'm security architect, but I also take care of the observability and security use cases that you can do in Snowflake. And as of my colleague, Jake.
Hi, everybody. My name is Jake Bukowski. I'm a field CTO as well. I run applied cybersecurity and observability here.
First, I want to give you a little introduction around observability. In the industry, they're also calling it OLI. So that sounds cooler, I guess. Because there are two ways of doing observability in Snowflake, and we're going to look into those. Then Jake will take it over, show you some examples and real-life use cases of real customers doing, getting value out of these use cases. And then I will show you how to get started with that using open source tooling. So using open source, the OpenTelemetry collector, and ingest OpenTelemetry traces, logs, and metrics in the OpenTelemetry OTLP format directly into Snowflake using Snowflake Container Services. So yeah, we can also discuss next steps afterwards. So let's get started on the first one, observability in Snowflake. Two things when people talk about Snowflake observability. The first thing is it's called Snowflake Trail. Everything that is Snowflake Trail means essentially Snowflake observability within Snowflake, right? You want to observe a container, you want to observe UDFs or stored procedures, check the logs, traces, and metrics of that. Or you want to, we also have, meanwhile, the ability to do AI model observability as well. You can instrumentalize AI models. So think of that, you have created a cool AI app on Snowflake, and now you need to know, does it really work out or not? Is there any, how does it behave in the real world? And you run some tests. Observability AI models means you have an AI model observing another AI model and judging it. So AI is a judge, and it shows you, so you're running different prompts with different models, and then it shows you how your model is reacting to it. And then you can see, it also shows you how accurate your AI as a judge thinks the response was, and how much context there was, and how it was fitting, all that stuff. So all of that is Snowflake Trail. That's the one thing. And the other thing is observing other systems outside of Snowflake, right? You want to observe your Kubernetes cluster. You want to observe a different infrastructure. You want to observe your applications, do APM, so application performance management. You want to ingest logs for cybersecurity detection. You can write detection as a code in Snowflake. So everything ingesting outside of Snowflake, that's the other thing. That's really what we are talking about here today, mainly how you can observe other things. But I just wanted you to know, to have this in the back of your head, this distinction. Yeah, you have seen a couple of logos before, I forgot. So there are different ways of getting stuff into Snowflake, Cribble and all. But let's jump to this. So Snowflake event tables. I'm just giving you a couple of examples now on the first thing, right? Snowflake observability, what can you do inside of Snowflake, observing Snowflake UDFs and stored procedures or container services within Snowflake. There are Snowflake event tables. They are the same schema as OpenTelemetry. So logs, traces, and metrics all within Snowflake in event tables ready for you to consume. Next thing is, this is how it looks, basically. So if you take advantage of it, you can see, your different spans, traces, and metrics there. And the event tables give you, so this is spans and metrics. And the event tables give you the logs, right? So let's talk a little bit, now that you have this overview, right? Let's talk a little bit about the value that it brings. So really, I think, to be frank with you, the real sweet spot is in the augmentation game. So you may already have been using a SIM system, XDR system, or Datadog, for example, for APM or other APM systems. And when it gets expensive, right, to have all these logs in those systems, you offload them into Snowflake, right? But we also have plenty of customers who have replaced those systems completely with Snowflake. So this is also not exotic or crazy. But if you want to get started, this is usually where most customers get started. So you're consolidating, first one, your data for fast investigations. So you can quickly search your data. You can combine security logs with observability logs in Snowflake because of the unlimited scale of Snowflake, right? and you can allow other security functions to work with the same data. So you have your SQL analysts, you have your threat hunters, you have your observability experts, so they can all come into the same platform. Maybe you want to take it over from here.
Yeah, so I hope none of this is new to anybody here, right? You think of Snowflake, not a lot of people think, oh, Snowflake, observability, cybersecurity. But if you kind of look at these value adds here, they're the things that you're used to, right? What are we talking about? We're talking about storing a lot of data. We're talking about auto-scaling. We're talking about the separation of storage and compute, right? When we're talking about looking at machine data, that's JSON, right? A lot of the time, right? We're talking about a variant that can query that without necessarily needing to put it into a structured table. So, right, what we're thinking about with Snowflake, it's the same thing, right? It's your Snowflake architecture. All those benefits come in. And what a lot of our customers have realized, not just because we're telling them this, but they're realizing this on their own, is that the value of a data platform is critical in today's world after the cloud. I work a lot with SIEMs. SIEMs are Security Information Event Management. This is where companies used to throw all of their security data, all of their logs, right? A lot of, Splunk, if we take a look at Splunk, right? You have observability teams in there for metrics, for traces. And it's great, except for the fact that it was built in a pre-cloud world, right? You have this thing, core-based licensing, which means you can't really have you have a concurrent query limit, right? You don't have storage and compute decoupled, so you have to pay more when you bring more data in. And what you end up with, a lot of teams have all this really valuable data that they want to observe their systems. You have network logs, right? Network logs are really important. Traces, forget anything else, traces. A lot of teams today, they're looking at metrics. They're metrics driven, right? Which is great when you're thinking about business metrics. When you're thinking about observability, you want to dig in a little bit more. You don't want to just know what was the average CPU when something broke, because we live in a distributed world too. You're not just looking at a monolith, you're looking at systems here, 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 here. You need a trace that's going to give you everything. But traces, a metric is one number, right? A trace is a massive amount of numbers. And if you're looking at a legacy system, you're not going to be able to afford to put that in. Or if you can, good for you. But a lot of companies won't. And what they're going to do instead is just not do it, right? Or just take a little bit of it, right? Which is fine until you realize that you need it. So let's talk about some use cases. I already kind of talked about one here, logs. So storing logs, right? We talk about very verbose data sets. We're talking about network logs. We're talking about, traces aren't logs, but we're talking about security. A lot of the times we're talking about CrowdStrike. We're talking about EDR logs, right? They're coming into Snowflake. A lot of times companies either can't afford to have them, or even if they can, right? A search is going to take forever, right? So what Snowflake allows is to bring in a bunch of logs and to search them at scale, right? We're going to be cost effective because it's going to be passed through pricing on the cloud storage. We're going to be able to say, remove this idea of rehydration. So there's this idea that if you just save everything to cloud storage or put it on tape or whatever you're going to do, that one day you can just take that. If you ever need it, you have it. You'll take it back and then you'll be able to search it. But that's a myth, right? Because rehydration takes time. It's expensive too. You got to bring all that data back into whatever thing you're using, right? So now I got to pay for it again. And that's going to take time as well. So you're going through an incident. Meanwhile, you're just clicking the button, waiting for those, petabytes of data to load. Whoever you work for that you probably never met before decided that just learned out that you exist, and now they're breathing down your neck. And so being able to search these logs at scale pretty easily, right? We have the variants, so we don't need to have structured data. We talk a lot about logs, right? A lot of logs are never parsed to begin with, right? Because you got to parse the logs, even if it is structured, right? People talk about normalization. Well, we're living in an AI world, right? We've had semantic views for quite a while, right? We're going to be announcing some really cool stuff soon, this week, right? But what does AI mean? Well, you still obviously want to normalize for your everyday searches, but for when you don't know what you're looking for, right? Why bother? Just again, you can throw a couple of terabytes in an AI, right? For an ad hoc investigation, help you along your way, right? You were taking things from vendor-specific tools to a very generic data platform that's scalable. And these are the use cases that we're looking for. Kevin mentioned augmentation. Augmentation is a massive play with us. People are thinking, am I going to replace Splunk with Snowflake? Well, theoretically, yes, we do have connected app partners. I'm going to talk about one of them in just a bit. But maybe they don't want to. Maybe you like the tool. You just, again, right, you want to augment. You want not just more storage, but other features that you could get in a data platform. You want AI. You want to train models, right? You want to run actually BI reporting, right? All these things, right? You want to build Streamlit apps, right? work really well on Snowflake. So what we see a lot of customers doing is having two sets, right? We have our SIM, or we have our, our APM tool over here. We have Snowflake over here. We got the historical data. We got the verbose data. Maybe we're actually doing computing here, right? Sending the events back there, right? And again, right? Benefit here is it's quick to get started. You're not, it's pay as you go, right? So you can try it out. Try it out. If you don't like it, turn it off, right? And it also prevents the risk from trying to migrate out of these old systems, right? If you have these older systems, you may have built them over a lot of years, and the people who built them aren't around anymore, and maybe they're not documented. And if you miss your deadline, well, A, you're missing coverage, right? So an incident happens, and suddenly you don't know how to debug it. You don't know how to get production back online. Or, right, you miss your renewal date. Now you got to pay for two things at once, right? An augmentation approach, potentially even augment to replace, will help mitigate this risk. You see a lot of people replacing Elasticsearch use cases. I want to say use cases here, right? Because Snowflake and Elasticsearch are both two completely different tools built on completely different engines. But what we see are there are different use cases that formerly used to work on Elasticsearch, but now can work very well on Snowflake. Why would you do this, right? Because if anyone here has ever managed Elasticsearch, great tool, but it is hard to manage. Even their managed versions are hard to manage, right? Snowflake, again, what's that benefit that we always say? We're managed, right? So easy to manage, not much you need to do. And then you can bring some of these workloads on. One of the things that we're very good at, these are not new features. These features that launched 2 years ago, if not more. Top K search, right? Finding that, or search optimization, finding that needle in the haystack. Full text search, which is kind of like token search, right? We brought all these features behind the scenes to all of a sudden give you parity, right? And in Snowflake, performance is cost, right? To Elastic. That's for logs, right? That's for logs. We have a lot of big customers. Here's a good example of Signia, who's actually migrated over to Snowflake from Elasticsearch. And we have, right, some of these other things where it's just documents. This is just a little shout out, nothing to do with observability, right? Cortex search has been known for kind of getting that replacement for that document search. Network log analytics, this is more of a security use case. So we talk about AI and ML on Snowflake. So let's see what we can do with AI. So everyone thinks about LLMs, but what about the other part of the transformer architecture? So I'm just going to call out so right now we have all these network logs in Snowflake because suddenly it's feasible and affordable, but we're using them for ad hoc. What else could we do? Well, we could do anomaly detection, right? So think looking for an outage, understanding if you've been DDoSed. Now, if you're the kind of company that needs to basically doesn't know if they're being DDoSed, you probably need to invest in understanding if you're being DDoSed, right? You're probably pretty big, pretty complicated, right? Because these things seems obvious, but they're subtle, right? And so this company here, a company called Deep Tempo, they took a transformer architecture, right? An LLM. LLMs are always trying to figure out what word comes next, what word comes next. They said, what if we tried that on logs, right? Logs are kind of like language. And then what if we flipped that on its head and said, well, if something comes next that surprises us, let's alert on that. That's probably something weird, right? That the end user wants to know about. And then I'm going to close with this before handing it back to Kevin. Observe, right? So I don't know why anyone would want to build their own observability platform, but observe unless you have a product, right? So this is we're talking, right? Could you replace a Datadog or a Splunk with Snowflake completely? So the answer is yes, you could, just like Observe, build your own full stack APM and everything monitoring tool. But you don't have to because Observe already did that for you. So this is one of our partners. You go on their website, you can actually just search Snowflake Observe, learn the whole story on why they chose Snowflake as their platform of choice. But something else interesting here, Observe as a partner integrates very well with Snowflake because it was built on Snowflake. Some of the integrations here they have, right? They can read data in directly from Snowflake. They can export, right? Directly to Snowflake. That's how you're going to do that ML, that AI, all those other things that you wouldn't expect in an APM tool, but you're not going to have to duplicate your data. They have an option of running as a connected app if you're highly governed and everything needs to be backed in your Snowflake account, right? So now you don't need another data processor, just keep it in your Snowflake. Again, right? Well, I got to pass back to Kevin. But again, right? Whole idea here, use the data platform that just works, right? Use something managed, use something scalable. So Kevin, back to you.
Okay, but we are builders, right? And we want to build our own stuff. And I'm going to now discuss with you how you can do this, how you can get started building this out. So here are the building blocks that you can use. So key elements here are Snowflake tasks and Snowflake stored procedures, right? For example, first of all, of course, you have to get the data in. So this is a key piece that I will discuss next, how you do that with native OpenTelemetry. This is the key thing that we'll discuss next. But I just wanted to see that what do you need to build this? What are the blocks that you need to think about? So you get the data in, right? Then you have, next you need detection as a code. You can build Snowflake stored procedures, or we touched, Jake, you touched on it already a little bit. I mean, good luck trying to use AI agents on unhydrated data, right? Somebody comes to you and says, okay, all these logs in Splunk or Datadogs are really, really expensive, so let's dump them into an S3 Glacier. And then the next guy comes and says, hey, can we build an agent on maybe do stuff with these logs? And then you say no, because I'm not going to get those logs back. So here with Snowflake Cortex agents is also something I will touch on next, because you don't need to rehydrate them. You can get those backs. And so this is another block. AI is a new block, right? But tasks, search optimization services, event tables, we discussed this, right? Native alerts. So this is also very important. Something is being ingested that looks funny, and you can trigger a Snowflake native alert via, for example, an API call to a downstream system. Think Jira ticket will be natively automatically created because of an incident that Snowflake detected, right? And also you can send out emails if you want. But anyway, so you see where this is going, right? So everything is sitting on the same platform. You can do orchestration. You can also run any other bespoke code and containers. So these are the things, and time series of the key thing, but Snowflake is probably the best database for time series anyway. So there's also blog posts. Everything we talk about, there are different blog posts that we can share with you. So this is the blog post that I wrote, and there's also the code, and there's the GitHub that is all shared with these materials. So basically, what I put together is that you have an OpenTelemetry receiver running Snowflake container services, and then all the other services, right? Azure, AWS, GCP, Kubernetes services, Splunk, Datadog, and what have you. Most of them already support OpenTelemetry or Prometheus or Jaeger or, these stuff is natively supported. And you can put this into, send this to an OpenTelemetry collector, and then batch this and send it to Snowflake, to an OpenTelemetry receiver, and just ingest it there, transform it into any schema you like. In the documentation that we are sharing with you after the session is how you can run a transformation on that into a common Elastic schema, and then, of course, store it in Iceberg, so you can query it with any query engine of your choice, right? DuckDB or whatever you like. And then you can have dashboards and Streamlit if you like. Also, PromQL or Splunk search engine or native alerts, Snowflake notebooks for threat hunting. All of that is in one platform. It's the key essence here. So you can get started with this. We have all this code available for you.
Thank you all very much.